Hi, everyone. My name is John Plunkett, Regional Sales Manager for DFI, and I would like to briefly discuss options for choosing the box for your edge application, the physical hardware you will use to implement an AI application in the field. We will discuss a little bit about the application space for the global AI market and how to choose hardware that supports both the processing power needed for the AI application as well as the environmental, dimensional, and expansion requirements for edge implementation. We will also share a couple of real-world applications and the solutions DFI provided. According to a recent market research study, the global AI market size was estimated at $87 billion in 2021, and it is expected to hit $1,600 billion by 2030. As you can see, AI applications cover almost all market segments and applications. According to the Harvard Business Review, in 2021, 86% of respondents said AI was a mainstream technology at their company. Some of the most developed applications are video surveillance for safety and crime, document and imaging processing, and object detection. Initially, AI solutions were cloud-driven because of the need for high-end hardware capable of performing deep learning computing tasks and the ability to easily scale resources in the cloud. However, as AI is required for more and more mission-critical real-time applications, hardware deployments on the edge are becoming much more prevalent. Edge AI addresses many weaknesses of cloud-based AI since they reside directly on field devices. Edge AI implementations can be real-time. Since data processing is local to the device, less data needs to be transferred and can greatly save on data bandwidth requirements and internet costs. Local implementations have lower storage and power requirements, and especially higher levels of security and privacy compared to a cloud solution. So Edge AI can be in the end a faster, cheaper, more reliable, more practical, and more private solution than cloud computing in many cases. When considering AI, you have to consider these factors. What type of AI computing power do you need? Can you use just a CPU based platform, or will you need a GPU based platform? How robust does the platform need to be? Will it be subjected to thermal or high temperature requirements? Is it outdoor? Does it need vibration and shock resistance? And then what about the cost? You need to compare the CPU versus GPA, as well as FPGA options. Do you need an AI optimization tool? And how will you go about deploying it? Also, you need to consider whether it needs to be a real-time application and how latency can affect that. Finally, there's power restrictions since you'll have a box in the field. So you want to make sure that you have the right power budget and the right battery time to support your application. So let's briefly look at some solutions. Edge AI platforms are tailored specifically for Edge AI computing and provide high computing power, GPU scalability for demanding AI tasks, wide connectivity with rich IOs and flexible expansions for easy integration. Edge solutions also need to be rugged and durable for different environments and use cases. For CPU-based applications, we partnered with Intel to provide the OpenVINO toolkit, a powerful AI software tool that speeds up implementation and has OpenCL kernels and tools for easy customization. To ease system management and maintenance, we provide robust management capabilities that are remote, often allowing for troubleshooting and repair without the high cost of going to the field. With the proliferation of around-the-clock global logistics and automated manufacturing, the demand for AMRs, or autonomous mobile robots, has grown rapidly. Here is one use case based on an actual customer of DFI's. AMRs use onboard sensors, cameras, and processors to move and transport other objects around without needing guidance. They require power performance for real-time calculation of positioning and map reconstruction algorithms. The system must have a versatile I/O interface so you can easily integrate a wide range of sensors and actuators. It needs to be low powered since you need extended battery operating time and you need to reduce the battery loss by frequent charging. It needs to be resistant to harsh environments. It can operate in a wide temperature environment for a long time. It has to resist signal interference and withstand vibration during movement. It needs a very robust wireless network so that it has stable and reliability transfer of data and control commands. And it needs to be a smaller size so that it facilitates the system integration and improves the flexibility of the robot design. For one of these applications, DFI proposed the EC70A-TGU, which is an ultra-compact control system that is only 7 inches by 5 inches. Powered by Intel's 11th generation Tiger Lake platform, it's powerful yet compact and suitable for being the control core of the AMR. The system is getting As you can see, the system supports a very wide range of uh, inputs and sensor capability and expansion capability. As mentioned, it's very small and it uses very low power. It can support up to 6 USB ports or 4 LAN ports. As mentioned, it's a very small and ultra compact unit. It is Ubuntu certified and uses the OpenVINO Intel system as mentioned before. Another application to consider is optical inspection. Typically, you would see this on an SMT line. So it needs to be able to support imaging and interface to multiple cameras. It has to have very high computing CPU and GPU support as the AI requirements are much higher. There needs to be a variety of interfaces and expansion ports so it can be connected to a PLC, light controls, motors, things like that. It must also support multiple cameras for different types of high-speed inspection. And once again, it does need to be able to endure, run industrial environments. For one of these applications, DFI recommended our EC300-CS. Once again, a very small box, but has much more capability, especially in terms of being able to support an MXM video card so that you can use the GPU to do much of the AI tasks. In this case, it used a RTX 3000, which supported 1920 CUDA cores and is capable of 5.3 teraflops of integer calculations. It is said that self-driving cars are the ultimate use of artificial intelligence and machine learning technology. Obviously, for a vehicle application like this, you're going to need to design a custom requirement. But before that, you need to basically develop your application. So DFI can provide systems where you can do the machine learning and get your application up and running ahead of time um, before you implement your custom solution. These type of applications require a very powerful computing and processing capability that can process multiple sensors, radar, GPS, camera, and other peripheral devices. There's a great need for expandable storage for enormous amounts of data acquisition, and also needs very high data transmission. This for these type of applications, you would probably use multiple GPUs. So in this case, we would use a standard industrial motherboard with multiple expansion cards to support this application. So as you can see, DFI proposed our WM343 ADS, which is what we call an AI training edge server, so that you can go through and do the machine learning and develop the application while you're developing the hardware. Um, as I mentioned, it uses a very robust industrial motherboard. And it's a very modular IPC system that can support whatever needs they have and will support add-in, Quadro video cards for the highest level of GPU performance. Here is another example of Edge AI boxes by DFI. This is an Nvidia-based platform, the ECS 100 series. It can handle multiple AI workloads and consumes very low power. Um, The appliance is powered by the Nvidia Jetson Xavier NX, and it delivers up to 21 trillion operations per second of throughput, and it is equipped with 8-channel PoE ports for IP camera video surveillance solutions, including traffic monitoring, license plate recognition, vehicle recognition, intrusion detection, and access control. This Nvidia Jetson Edge AI system is the perfect platform for intelligent transportation, smart city, smart factory, manufacturing, and more. So as a quick review, we provide basically 3 different levels of Edge AI hardware that you can use for your application. The first are robust and reliable small form factor boxes that can be put into industrial applications, outdoor applications that use the CPU for the AI compute factors, and can provide a very strong solution in the field. Up from that are still very compact systems, but that support much more expansibility so that you can use MXM or graphical PCI Express cards. They have multiple expansion slots, so you can increase that. And these allow you to do higher end machine learning and AI applications. And then at the very top end, as we mentioned, we can use mother-based solutions for very high performance training servers. They can support Xeon processors and support, 224 cores, as well as up to 4 add-in GPU cards for additional processing power. So what does a hardware provider supply for Edge AI applications? They provide a variety of platforms and acceleration cards for customers to choose from. It's very flexible and highly reliable designs that you can tailor exactly to your specific requirements. We work to you to come up with the best solution that works for your particular application. That concludes my presentation. I want to thank everybody for their time, and I'll pass it off.